Okay, hi everybody. I'm Daniel. I'm the executive director of the Julie Robinson Mathematics Festival. Today we're going to be doing one of my all-time favorite activities. But before we do so, I just wanted to share a little bit about what the Julie Robinson Mathematics Festival is all about, and some of the resources that you can find on our website. So, is it okay if I take over screen share?
Absolutely. I guess that means I have to probably turn mine off, which I will do presently. I think you should have
Yeah,
it.
I'm good. Um, So this is a Julie Robinson Mathematics Festival. You can see a video playing on our website, jrmf.org. Since 2007, we've primarily done stuff in person. And so a math festival is just a big open space, lots of tables set up. Every table has a different manipulative based, play-based activity, either puzzle, game, crafting activities, stuff like that. Every table is a trained activity leader. Um, who we train on things like introducing the activity, asking good questions, really building that critical thinking and problem solving skills as students explore the different activity. And then we open up the space for anywhere between 2 to 5 hours, and we let kids just explore. We give them the agency to choose what they want to do, where they want to go, for how long they want to do it for. Um, some students will hop around all the different stations. Some students will stay in one station for many hours, and that's totally okay. Our ultimate goal is we want students to be able to leave the event feeling more confident in math and feeling joy in math. And so we build all of our activities around this, is developing those critical thinking skills, those problem solving skills, and building student confidence and joy in math. Sorry, my computer's about to die. Hold on.
White Daniel's getting
There we
plugged.
go.
We've helped organize Julia Robinson festivals there in the Navajo Nation and are willing to do so. So that's something to reach out to us if you wish such help.
Yeah. And our second ultimate goal is not only to create fun math events, but to help other communities do it, just like what Dave was saying. We provide all of the resources and services you might want when planning an event like this. We provide all of the game and puzzle resources. We help you out with all of the handouts. We have printing guides, purchasing guides, so you can create events just like we do. And then we provide free trainings for volunteers. If we're in the area, we'll do it in person, but if we're not, we'll do them virtually over Zoom, kind of like what you're about to experience in a moment. And then we also do event consulting, so things like helping people choose a venue, do marketing, reach out to volunteers, reach out to students, all that good stuff. So I'm going to stop rambling about this. If you do have questions about any of this stuff, feel free to always go to our website at jrmf.org, or also feel free to email me with questions. I love answering questions. I love chatting with people about what we do. But without any further ado, one of the things that I think helps people the most when trying to learn about what play-based math is all about is getting to experience it for themselves. So that's what we're going to be doing for today. We're going to be going over one of my all-time favorite activities called river crossings. This activity is designed for third to eighth grade students, but we've used it with students of all ages, anywhere from as young as kindergarten all the way up through 12th grade. And we design all of our activities to be low floor, high ceiling so that really anybody can enter into them and understand what's going on, but there's a lot of depth and there's always new challenges to explore. So I'm going to explain this the same way that I would explain this to a student. We're going to go over the app really quickly, and then we also have a Desmos that just, again, builds that deeper metacognitive thinking in students. So we'll go over that too. So what is river crossings? So you have a boat, you have three items, a wolf, a goat, and a cabbage, and you're trying to get all the items across the river safely. If you ever, at any point, leave the wolf alone with the goat, the wolf eats the goat, which is not good. If at any point you leave the goat alone with the goat eats the cabbage, which is also not good. And following those two rules, the goal is to get everything across the river. And so my first question to you all, we're going to solve the first couple together as a group before breaking out into breakout rooms, is what do you think I should take first?
The goat.
Okay, so we can take the goat over first and nothing gets eaten. That's good. What should we do next? And feel free to put suggestions into chat, say them out loud, whatever you prefer.
So a question. So if the cabbage goes across to the goat, will the goat eat that on
That's
the
a
other
great
side?
question. And my favorite response to questions like this is let's try it out and see what happens. One of the ways that we design these apps is with lots of undo buttons, restart buttons. So even if a mistake happens, we make it very low risk. So if we were to bring the cabbage over, we see that the goat doesn't eat it. And the reason is because you're there. So as long as you're there, you're kind of acting as kind of the babysitter. You keep order on your side of the river.
Okay. So I would have said the cabbage and then the wolf.
Okay, so we brought the cabbage over. Now if we go try to get the wolf, well, now I leave this side of the river. So I'm no longer babysitting and the goat eats the
I
cabbage.
see. Maybe you keep the goat in and bring the wolf across.
Okay, let's try that. Okay. And then how do we finish the puzzle?
And you can't have two in there, right?
Correct. So what should I do to finish getting everything across the river?
Go back and get the goat.
Yeah, so we can go back, grab the goat. We got everything across successfully. As with any good math puzzle, the goal is to get the confetti, and we got the confetti. And as you can see, we have lots of different puzzles for this. So what we're going to be exploring in a moment is the puzzle sequence I have in the app that follows along with the Desmos. But before we do that, I just want to go on to one more puzzle together as a group before we dive into the breakout rooms. So this is puzzle 2. To get to the puzzle, you just click on the little arrows up here. And can anyone just quickly tell me what is the difference between puzzle 1 and puzzle 2? What changed?
The number of goats.
Goats.
Yeah, so now I have 2 goats instead of 1 goat. Okay, so it's the same puzzle. Our goal is to get everything across the river. And so my question to you is, how do we start?
So in the first puzzle, I noticed that the wolf did not eat the cabbage.
Correct.
But the goat, when you left them on the other side. So now you'll have to move move one goat over. Oh no.
Here, oh no. No, that's good. So what do you predict is gonna happen if I move 1 goat over?
I think the
Gonna eat the cabbage.
The goat's gonna eat the cabbage. And let's see. So if I do bring this goat over, let's see if our prediction is right. So not only does the goat eat the cabbage, but as it's gnawing on the cabbage, the wolf also eats the goat at the same time.
Yes.
Okay, so we can't bring a goat over.
wolf goes across first, I think.
Okay, so if we try to bring the wolf across over first, anybody have a prediction as to what's gonna happen?
The goat's gonna
Oh,
eat.
So let's see if that happens. So we bring the wolf over and we do see that even though there are 2 goats, they share the cabbage and they both eat them.
Two goats can gang up on the wolf.
And let's see if that's true. So if we leave the 2 goats together with the wolf, the hypothesis is the 2 goats are going to gang up on the wolf. Let's see if that is really true. And we see even though there are 2 of them, the wolf still overpowers and eats both of the goats.
And you can only take 1 across.
Correct.
You can't.
And can you explain a little bit more? Why do you say that you can't? Or how did you come to that conclusion?
If you take the cabbage, the wolf eats the goat.
Mm-hmm.
If you take 1 goat, then the goat that's left over eats the cabbage and the goat gets eaten by the wolf.
Yeah, and so we've kind of tried all the different possibilities. And so there is a hint to the solution to this puzzle on the screen, and it's this little impossible button. So if we don't think it's possible to get everything across, we can always click this. And just because kids sometimes like to click this button a lot, we have an extra button just to give them an extra second to think about it. And so what do you think? Do we think that we should check to see whether or not this puzzle is impossible?
Yes.
Okay, so I'm going to click the check button. We got purple star. Purple star means that this puzzle is truly impossible, which is why I always like to show the first two. And this is something that we like to include in a lot of our puzzles, is to show students that math problems don't always have an answer, and that's sometimes okay. The fact that this one is impossible is the answer for this puzzle. And it's something that kids don't often get to see in the classroom. So often, you know, X is always equal to something. Not always, of course, I'm generalizing. But we want to show students that there are lots of different possible answers for them to consider when doing stuff like logic puzzles. So the last thing I want to show before we do break out into breakout rooms is we've also created a Desmos for this.
Okay, so we're doing a breakout room, so don't ask me a question this time, okay? So just a breakout room. I think it will just take probably 5 to 10 minutes, so.
Sorry, can you say that again? Okay. So in addition to the app, we're also using a Desmos, and I'm going to share links with all of this in a moment. Well, the way the Desmos works is I'm going to share a link into chat. We're going to put that link into here. Not that, sorry. That. You're going to get something like this. You can just click continue without signing in, enter your name. I'm going to enter my name. It'll give you a little brief intro to the Desmos. You're going to click this next button in the top right, and you're going to get to the first question. And so the Desmos goes along with the app. You're going to need both of them to answer the questions. And so we've already done puzzle 1 and puzzle 2. And the very first question is, one of these two puzzles is impossible, and what makes it impossible? So can someone just give me a brief answer as to how I should answer this first question on the Desmos?
Puzzle 2 is impossible.
Okay.
Because
After we finish the statement.
Because of the 2 goats.
Perfect. And so when you're done, you click share with class, and you'll see up to 3 other responses that other people put in as well. Of course, no one's put in any responses yet, so I don't see anything here. And then once you're done with that question, you move on to the next question, and it'll tell you what puzzle to try next. So the next question asks you to try puzzle 3. You'll go back to the app, go to puzzle 3, try puzzle 3, and answer the question. Again, the goal with the Desmos and with all of these questions is to develop critical thinking skills, problem solving skills, pattern recognition, and creating strategies. So that's kind of the goal of this activity for today.